Welcome. In this podcast, we're going to discuss graphing functions and the role that the graphing calculator can play in graphing functions. When you have a single variable equation, such as 3x equals 6, your solution is just a single number. Divide both sides by 3, you get x equals 2. Tells you just about all there is to know about the solution. But when you have a multiple variable equation like 2x plus 3y equals 6, your solution is an ordered pair of numbers, and in particular there are infinitely many of those solutions. One such solution, for instance, would be x equals 0, y equals 2. Because if I put in x equals 0 here, I get 0. If I put y equals 2 here, I get 6. And 0 plus 6 is 6, so that's a true statement, so that's a solution. But so is 3, 0. If I put in x equals 3, I get 6 here. If I put y equals 0, I get 6 here. And so 6 plus 0 again is 6. So we have two solutions, and in fact, we can just go on doing this all day. Every time we pick a value for x, we'll get a different value for y, which is a new solution. And so how do you come to grips with something like an infinite number of solutions? Well, in the case of the solutions to this particular problem, it turns out that this is the graph of a straight line. It's a graph of a straight line that goes through y equals 2. So it looks a little bit like this. If we just mark off the axes this way for a crude graph, y equals 2 would be right here. It's a line that has a slope of negative 2/3. So when you rise negative 2, you run 3, so another point would be here. So it's a line that looks like that. And perhaps there's something that could be gained in knowing that the set of solutions to this equation forms this straight line that looks like this. Well, that's kind of where we're going to go today. We're going to look at characteristics of functions which determine what their graph looks like. And the reason we're going to do that is because there isn't any number of points that you can graph that tells you what a graph looks like. For example, if I were to look here at this example at the top and I've plotted 4 solutions to the function that this is the graph of, and the 4 solutions line up in a straight line, I would be tempted to think that I was graphing a straight line here. But how do you really know that you're not graphing something like that? Because that also goes through the 4 points. And you see, there's not enough points that you can ever graph to tell you what a graph looks like. You have to know what a graph looks like from its algebraic structure. Graphing points is not enough. You need to know the shape. So what we're going to do in this podcast, we're going to talk a little bit about the shapes of what are called polynomial graphs. Now, a polynomial is a particular kind of function, and I'm not going to try to get real technical here with you. I'll just give you an example of a polynomial function and let you kind of assume for yourself what they look like. But here would be a typical polynomial function. Y is equal to 4x cubed minus 3x squared minus 11. That's a polynomial function. These terms are called monomials, and when you put some monomials together, you get a polynomial. And basically, they're monomials if the x stays on top, and if the exponents are non-negative integers, that's exponents of x. Exponents of the constants doesn't matter. The constants can be anything in any form. But functions of this form have an interesting property which I'm going to demonstrate to you now, and which is going to be very, very helpful as we try to graph these polynomial functions. And the interesting thing about their shape is in this little comment box below. Polynomial functions of degree n. Now, the degree of a polynomial function is its highest power of x. So if this is your polynomial function, that's of degree 3. If this is your polynomial, the first term is of degree 1, that's a 1 understood. The second term is of degree 2, that's a second power. The last term, you can imagine, has a little x here, and I'm making it dot because it's invisible, and a 0 power, because anything to the 0 power is a 1, and that's just 2, and 2 is the same as 2 times 1, so you can imagine a little x to the 0 power here. So we have a term of degree 1, a term of degree 2, and a term of degree 0, so we would say this polynomial function is of degree 2. We go to its highest degree. Now with that in mind, take a look at a rule for the number of turns in the graph of a polynomial function. Polynomial functions of degree n have at most n minus 1 turns. Now I don't just want you to take my word for that. I'll give you a little demonstration of it here. And I'll do that by bringing up this calculator, turn the calculator on, and we're going to graph 4 functions of different degrees. In the first function, the degree is 1 understood. I don't show the degree, but it's there. In the second function, the degree is degree 2. In the third function, degree 3. And in the fourth function, degree 4. And we're going to look at the number of turns in the functions. Now, in order to graph them, we first have to get them into the calculator. So you go up to the graphing screen, and you use the keys right below the graphing screen to enter your data. So I'll hit the y equals button. And as you can see, I've already entered 3 of my 4 functions. I've entered the degree 2 function here, the degree 3 function here, and the degree 4 function here under y4. And now I'm going to put in the first function, and I just did that to save time. And I'm going to put in the first function, the degree 1 function, but I'm not going to show to the 1 power. When something's to the 1 power, typically no power shows. As you can see, every time I touch the screen, the calculator disappears, so I have to keep bringing it back. Okay, let's take a look at how we would enter this. The reason I saved this one to enter last was because of this coefficient of x, negative a half. When you're entering a fraction into your graphing calculator, always put it in a bracket. Not doing so can cause you a lot of trouble. So I'm going to put this negative a half in a bracket. I'll go open parentheses, negative sign, 1 divided by 2, which is a half, close parentheses. And then it's 1/2 x minus 4, so I hit x with the x t theta key, minus 4. And now I've got all 4 functions in my calculator. But notice the equal signs on the functions. The top one is highlighted dark. The next 3 are not highlighted. The calculator can only see the highlighted keys. I'm sorry if I have to keep pausing, but I've got a cough and sometimes I have to stop, clear my throat. So the only one of these 4 functions that the calculator is going to actually see is the highlighted one. Since the degree of x is 1, if our statement here that polynomial functions of degree n can turn at most n minus 1 times, here the degree of x is 1, so 1 minus 1 would be 0. So this should turn 0 times, so we're going to graph it. I'm going to graph it by using my zoom key here. If I hit my zoom key, a lot of zoom options come up. Zoom 6 says zoom standard. Zoom standard gives me a standard window. I'll show you what that means right here. I've hit zoom, I'll hit 6, and you can see a screen comes up. And to show you what I mean by the standard window, I'm going to hit the window button. And it says x min is negative 10, x max is 10 with a scale of 1, y min is negative 10, y max is 10 with a scale of 1. If I go back now to my graph, notice my window. It starts here. There's 10 marks coming out this way, so it's starting on the x at negative 10, going to positive 10. Starting on the y at negative 10, going to positive 10. But notice how much shorter it is in the y direction than it is in the x direction. So even though both axes have 20 marks, the marks in the x direction are much bigger than the marks in y. So that's what we call a standard window. You can graph in that window hitting a zoom 6, but we'll also show modifying the window settings. Okay, well, it worked out all right. The equation of degree 1 had 0 turns. It never turned. It gave us a straight line. Let's take a look at the next function. If I highlight the next function, it has degree 2. If it is the case, and I highlight that one, if it is the case that the graph can turn one less than the degree of the equation, then we should get a graph with 1 turn. So I'm going to hit graph button here. I'm going to hit the graph button here. The first thing that'll graph will be the degree 1 equation, so it'll have no turns. The second thing that graphs will be the degree 2 equation, so you should observe 1 turn. Here's the degree 1 equation, no turns. There's the degree 2 equations, 1 turn. It's kind of small. I think what we'll do, since we don't have a lot of information out in this part of the graph or in this part of the graph, and since I'd kind of like to do this anyway, I'm going to do a little window adjustment. I hit the window key, and instead of taking my x all the way from -10 to 10, I'm going to cut back on that a little bit. I'm going to take my x from -6 to 6 and just hope that that's enough. Whoops, that didn't do it. Window, you have to arrow down first so that you're on the first one. Then hit -6, enter, 6, enter. Now my X window should be much bigger spaced. It should, basically what it's going to do is it's going to expand the width of the graph by doing that. So let's hit graph. Here comes my first function. Notice now instead of 10 marks to the end, there's only 6. And this 1 turn graph now looks a lot bigger. We get a little bit more information out of it. Okay, let's take a look at the next function in our list. The next function was of degree 3, so we expect 2 turns. So I'm going to go ahead and highlight this equal sign so the calculator can see that. I'll bring my cursor down, I'll put it over the equal sign, and then I'll hit the enter button, and now it can see the first 3 graphs. So this should be no turns. Degree 2 should be 1 turn. Degree 3 should give us 2 turns. Let's see if it works. Here's degree 1, no turns. Degree 2, my 1 turn. And degree 3, it came down like this. It made a big turn, came up to here, made a second turn, and came down. So degree 3 did indeed have 2 turns. Let's go ahead and add the last function in. Now this last function is of degree 4. It's x to the power 4. Again, I'll bring my cursor down to the 4th function. I'll arrow to the left till I'm over the equal sign. Then I'll hit enter to highlight the 4th graph. And now let's graph and see what we get. Starting off with degree 1, 1 minus 1 turns. Degree 2, 2 minus 1 turns. Degree 3, 3 minus 1 turns. And finally degree 4, it came down like this and made a turn, came up here and turned back down, made a 3rd turn, and then went on up to infinity. And so you can see degree 1, 0 turns, straight line. Degree 2, 1 turn, parabola. Degree 3, 2 turns. And degree 4, 3 turns. Now I'm not saying that degree 4 has to have 3 turns. What I am saying is that if it's of degree 4, it won't have more than 3 turns. If it's of degree 3, it won't have more than 2 turns. Well, there's some real valuable graphing information, and we'll use that in the next podcast, but we're not going to use it right now. Right now, I want to go take you to the next part of this, which is called tables of values. How do you graph by hand, and how do you graph by calculator? So I'm going to make myself a little graphing grid right up here. Not going to do a real super job of it because I'm just trying to get a point across here. I'm not trying to make accurate graphs at this particular stage. We'll do that in the next podcast. Just mark off some units here. You can get sort of good at this if you practice at it. So there's a grid for us. And how would we graph this function y equals 2/3 x plus 1? Well, what we need to do is we need to find some solutions. We need to put in some values of x and see what y's go with that. Notice here that whatever x is, it's going to be multiplied by 2/3. So if I choose it wisely, I should be able to cancel out that 3 and make it easy to figure out what y is. So for my first one, I'm going to try x equals 3, because that's going to cancel out the 3. The 3 will cancel the 3 here, and I'll be left with the 2. So if x is 3, the 3's cancel. I get 2 plus 1, which is 3 for y. And so I would graph that by going 3 to the right, 3 up. And there's that point. And then if I wanted another point, I'd again like to cancel out the 3 if I could, so maybe I'd use x equals -6. Then right here, I would have the number -6, so it would be 2/3 times -6 plus 1. Well, the 3 would cancel the 6 and give me a 2, so I'd have 2 times -2, which is -4, plus 1, which is -3. So that says if I go 6 to the left, 1, 2, 3, 4, 5, 6, I'll go 3 down. That gives me that point, and there's my line. Now, rather than making all these parentheses and commas every time, what we normally do is we do this in what's called a table of values. If I want x to be -6, I make a little t, put x on one side, y on the other, put a -6 here. I plug it into my equation. If I get -3 for y, I put it here. And while it causes me a little extra trouble at the first to set my table up, now I can do my solution pairs without making any more parentheses and commas. So it's a little bit of a time saver, and that's all it is. Normally when we're trying to graph something, we want to graph to the left and the right, so I'll use some negative values. Here I'm using multiples of 3 simply because of the 3 in the denominator. It's convenient to be able to get rid of it. And then I put my y values to the other side. So going back to my earlier work here, if I put in x is -3, then I have 2/3 of -3 plus 1. The 3's cancel, so I get -2 plus 1, which is -1. If I put in x equals 0, I get 1. X equals 3, I get 3. X equals 6, I get 5. And when I plot all those, I get this graph. Here's my -3, -1 right here. Here's my 0, 1 right here. Here's my 3, 3 right here. And here's my 6, 5 right here. And there's my graph. Now, is there a better way or an easier way to get that table of values? Well, there is if you have a graphing calculator. The first step would be to put that function into your calculator. Well, the calculator's turned off, so I'll turn it back on here. I'll get out of my graph and go to my y's, so I can put this function y equals 2/3 x plus 1 in. Okay, I don't want to graph these other functions. That was for the other demonstrations. So I'm going to arrow over onto the equal sign, and I'm going to make those invisible to the calculator by just going down and hitting enter until I've taken the highlights off all of the functions. Now, none of the functions are highlighted. And I'll go down here to function 5, or I could go up there and replace this into function 1 if I wanted to, but I'll just go down to function 5, and I'll enter the function y equals 2/3 x plus 1. And remember that since that's a fraction, I'm going to want to put that in a bracket. So I'll say open parentheses, 2 divided by 3, 2/3 x plus 1. And now I've got that in, and notice that even though all these functions are in, they're not highlighted, which means the calculator can't see them. It can only see this function that I'm trying to graph. And I'm going to take it onto a standard window just to kind of remind you. If you want to do a standard window, you can just hit zoom 6, and you'll get the graph in a standard window. However, what we were looking for was a short way to get a table. So notice right here, and you might not be able to see it on the podcast because the printing is so small, but if you go to your window key right underneath your graph, right above that it says table set, TBL set. And what that is that's setting up a table of values. So I'm going to hit second window, and that brings up my table setup, and it starts off, it says at the top table setup. Then it comes down and says table minimum. What number is going to be the smallest number in your table? Well, in the table that we set up, our smallest x value was -6. So for table minimum, I'm going to put -6. Then there's this funny little sign. It looks like a little house followed by the word table. That is actually a Greek delta. And what it is it's how much you want to add to your smallest value to get your next value. Now notice that we were going by multiples of 3, so I'd like to add 3 so that my next value would be -3. So for delta table, come down here and I put 3. Now once you've got that table set up, all you need to do to see your table is hit second graph. So second graph, it says table above that, and take a look at our table. It says, and this must be in scientific mode because it's got all these E's on it. So let's go to the mode key and get out of scientific mode. Yep, sure enough. See here, scientific highlighted. Let's arrow, well, we're already on normal. Let's just hit enter. And now we should have a normal looking table. So again, go second graph. And now our table looks normal. And it says when x is -6, y is -3. That was our first table entry. When x is -3, y is -1. Second entry. 0, 1, 3, 3, 6, 5, just like our entries. And now if we were graphing by hand, we'd have a ready-made table of values to graph with. That's a feature of our calculator we'll be using quite a bit. And that completes our podcast. And we'll pick up with some more graphing in the next podcast, where we'll start to really use some of the powers of this calculator. And that completes our podcast.